Linear functions. In the word linear, there's like 5 words, maybe more. One is...
Line.
Oh, bummer, you picked the one I was going for first. Another one would be...
Ear.
Ear or... In.
R.
R. Pirate word. The one I was going for is the line. So this section here is linear functions. And after this, I will be on track, I promise. But if you're talking about a linear function, if you graph it, it's going to be a nice straight line. So should be every question in this section, except for maybe some review ones at the end. If you're getting a graph that's not a line, not a straight line, you're probably doing something wrong. So basically, linear functions mean line. Functions, if you go back to functions from section 1, we said that each x value, so for every point on this line, no one x value can have 2 different y values. So if we were to try to look at that, what does that mean as far as our lines go? What kind of lines can we have or what kind of lines can't we have? So something is not a function if one x value has 2 or more different y values. So I need a nice looking number. 15.
28.
Okay. So if we say like right here is the point 15, 0. See if I can squeeze it in there. 15, 0 is right there. If I were to do 15, 10 then, for my second point, do you agree it might look something like right there? And if I were to do 15, 20, it might look something like right there. If I were to do 15, 5, maybe, I don't know, right about there. But all those points, if I drew it correctly, if I have one x value with multiple y values and draw a line through it, what kind of line am I going to get? It's straight, but it's also straight up and down, so...
Horizontal. Oh, vertical.
Vertical. So if we take points that aren't a function, we get a vertical line. So in other words, if we're talking about linear functions, we're going to have 1, they have to be a line. 2, in order to be a function, they can't be vertical. So can't be vertical. So in this section, we should be graphing a whole bunch of things that are going to be lines, but they won't be vertical lines at all. Okay, speaking of graphs, this is probably going to be a repeat of stuff you've learned in science, but if we have an x and a y, x always goes on which axis? X always goes on the horizontal. So x always goes here, y always goes here. Now, one of those variables is dependent, one is independent. The dependent variable is y. So, dependent. I probably would if I were you. Write it down. So the dependent variable will be the y value, or on the y-axis. The x value then is going to be the independent. Often in like the story problems, often they have time. Time is pretty much always going to be the independent variable. But you could look at like what's the length of the grass in the lawn compared to like how much time goes by. So the length is dependent. The length of the grass depends on how long it's been since you mowed it. Or you could say how heavy someone is. Depends on how many chocolate milks they drink. You know, if you drink way more chocolate milk, you tend to be heavier or something like that. So y depends on x. When we write the equation for that, you're going to get, typically our equations are going to be y equals something with an x in it, right? So for example, y equals 3x or y equals 5x plus 7 or something like that. I'll just make up one. Nothing really special about it, but y equals 5x plus 2, why not? But the point I'm trying to make is that typically the variable that's by itself is going to be the dependent variable. So I'm going to write it here underneath the y. Dependent variable. Equals the other side, the side that often will have numbers and stuff with the variable, is going to be the independent variable. So I'll just write something with the independent variable. Independent variable. And those are supposed to kind of line up to like my equation above. But that's one way to tell what the dependent variable is rarely, if ever, is the dependent variable going to be stuck in here with a whole bunch of numbers and have the independent variable by itself. They just don't do that. Questions up to here? The book likes giving you charts that look something like this. So I'm going to write down an example, and I'm going to go with 3 columns. This column is going to be my input. My second column is going to be the function. or the book will often refer to it as like the rule. That's kind of like in my previous one, like the 5x plus 2. It's what's the rule to get you from one variable to the other. And then my last column will be the output. So the input, we typically take and put a number in for x. Going back here, typically you say, okay, when x is 4, what's the y value? When x is 7, what's the y value? So x is kind of like the input. The output is going to be the y value. And then the rule, so what did I put there? I did 5x plus 2. So maybe we'll stick with that. So we have 5x plus 2. That's just kind of like the equation. The y equals what? It tells you how do you get from an x value to a y value. Now if we were to pick some x values, maybe if I pick an x value of 0, now my rule becomes 5 times 0, because x is 0 plus 2, gives me a y value of 2. Then my next x value, maybe I could say, is going to be, why not, we'll put in a 1. So then I have 5 times 1 plus 2 gives me us 7. So we have a 7. And maybe pick one more. Maybe we'll go to like a 3. So 5 times 3 plus 2, 17. So if we have these, you could at this point go through, and this would be the same as if you got a question that said graph y equals 5x plus 2. I just wanted to show you kind of how the book does it in this table format there. If you wanted to graph something like that, a lot of times people will jump to like the graphing calculators, and they'll hit the y equals button. So first go to the upper left, they'll hit the y equals and type in 5x plus 2. And then when they're done with that, they'll go over here and they'll hit the graph button, see what the graph looks like on the screen, and then try to copy it down on the little piece of graph paper on their quiz, on their test, maybe on their homework. People that do that typically get it wrong because they'll get kind of about the right direction, but it won't be exactly where it should be through the right points. What's going to be a whole lot better is hit your y equals, put the equation in, and then up above graph, it says probably in blue or yellow, it says table. So if you hit the second key and then your graph button, what it's going to do is it's going to list, kind of like we had here, it's going to list a table. So it'll give you points like it'll have like an X and then a Y1 column. And you can scroll up and down to see what you want. But you'll have like a 0 and a 2, and then a 1 and a 7, and then a 3 and a 12. I guess it'll have like a 2 and 3 and 17. No wonder it wasn't working in my head. 3 and 17. But it'll have like the 2 and the 12 in the middle there. But you can scroll up and down. So much better way to graph the things. Either make a data table, kind of like we did here, or use a graphing calculator or that app on like an iPad or something like that. Not legal on the quizzes because there's tons of other stuff there. But use some sort of a application to give yourself a data table. And now you can go through on your graph paper and put in your nice dots. So I have 0, 2. I have 1, 7, I have 3, 17, get some dots and then put a nice straight line through them. Is that fair? That's it for the section. I can show you more graphing calculator stuff in class if you want, but I think we've done that before, right, the data tables? So, yeah, sure good.